Hey, microphone. Cool. What's up, guys? Thank you all for coming to this Bay Area Druid meetup today at this beautiful office with this nice food outside. I'm Gian Merlino. I'm a committer on Druid, PMC member on Druid, been working on it since the beginning. Co-founder of Imply, a company based around Druid. I'll talk more about that in a bit. But anyway, thank you for coming. Before we get going, I wanted to ask how many of you all are using Druid today? Oh wow, nice, awesome. How many of y'all are not using Druid, but kind of trying it out, kind of interested in learning more? And here for the food. Okay, cool, so like a third, great. That's better than normal. All right, so without further ado, our first talk is from our gracious host at Pinterest about what they are using Druid for, powering ads analytics with Apache Druid.
Cool. Thank you, everyone. So welcome to the Pinterest office. My name is Filip Jarosz, and I'm a software engineer on the ads data team here at Pinterest. And on the team, we spent the last year actually implementing Druid into production, from basically nothing to now serving all of our ads metric requests using the new platform. So I'm excited here to tell you about our journey. So first, a little bit about Pinterest ads history, I guess. We launched the ads product actually in the year 2014. And at that time, we had maybe fewer than 5 advertisers actually getting ready to go. And we didn't really care too much about how the platform looked like, how we were really calculating the data, how we were really reporting the data, because at that time we were just focusing on business expansion and kind of making sure that more advertisers would come onto the platform so that our business would grow and we wouldn't have to close the doors. So fast forward to about 2015, 2016, when we met 100 million monthly active users, and we started to notice some deficiencies of the existing stack, particularly in the ingestion pipelines, right? They were getting slower and slower every day, and at some point it even took maybe longer than 24 hours to actually give the data to our advertisers. So obviously that wasn't acceptable, and we had a ads team-wide effort to really fix those pipelines and re-platform everything and rewrite all this conglomeration of Hive and MapReduce jobs into Spark, and we had really good success with that. So that was about in the year 2017 when we launched that, when we just hit 200 million monthly active users. But then we started to see, okay, ingestion is okay now, so what are we gonna do about the query side of things? And it turned out that as we had more and more advertisers, each of them were really requesting different slices and cuts of the data. Everyone wanted to see their metrics a little bit differently. And the system that we were using at the time didn't really support that. So we said, what's next for us, right? And we chose Druid to be that. So a little bit more about the current system. Again, we launched in 2014, and at that time the system was backed by HBase, which is a key value store, right? At that time, that was kind of the industry standard. It was scalable, it was familiar to us. At Pinterest, we knew how to operate that platform, and it was really the industry standard. So it remained unchanged, again, as I said, because we are focusing on fixing the ingestion part first, until about 2018, like a year ago. And it was just at that point unable to scale. So we were like, well, what are we gonna replace HBase with? And we chose Druid. So why did we do that? Namely because Druid met all of the keywords that we really wanted to meet with this new platform, right? It's like, oh, you can ingest a whole bunch of data. It's going to pre-aggregate it for you. It's going to be fast, have all these fancy analytical queries that you could want. It's going to version your data in case you make a mistake in your ingestion and want to re-ingest some data into the system again. It's going to have approximate algorithms, which if you have, for instance, you want to know how many unique users have seen your ad in the last month, so it can actually perform that operation, which is, to answer exactly, very difficult. It can do it very quickly. It has a SQL interface that is very intuitive, but first and mainly, it's easy to understand code, and it has a very supportive community led by a lot of open source developers and Imply, right? And when we were first getting started, Imply actually helped us with writing our first POC, and they were very responsive. Every single time I would check up on us throughout that process. Hey, how's the Druid implementation going? You know, do you have any questions? Like Gian would write me an email, and then usually I would answer with like 2 pages of just, oh my God, it's not working, help us please, we're completely drowning. But finally we got through that, and now we have launched into production, and we're actually very happy with it. So first, when we were thinking about Druid, right, we were thinking, okay, how do we get the data into the system? So Druid supports 2 modes of ingestion, native and Hadoop. And pretty early on, we knew that the native ingestion isn't going to work for us because we just have too many events, right? Billions of events that come into the platform every day. And all it does is really launch a thread on one of the middle manager machines, on one of the ingestion machines that reads those events line by line and makes the Druid segment files. So that was too slow. That really didn't work for us. And then we tried the Hadoop ingestion, which basically does the same thing but in parallel, right? Launch a MapReduce job and builds those index files in parallel. So that worked, but it has a number of pain points. The first one is that Hadoop, to set up a separate cluster for the HDFS and MapReduce to do that ingestion, that's pretty painful. And also, the other thing is that we don't really have a single pipeline that is actually writing all of the metrics that we serve our advertisers, right? We actually have multiple pipelines in the company that do that. And as a result, we need to have multiple pipelines that at a different time write the data in, but then actually we want to answer queries about that data together. So for instance, we might have my team that is writing all of the events that happen on Pinterest, like somebody on Pinterest viewed an ad, clicked an ad, but then also we have another team, our team called Ads Measurement, that they work out of the Seattle office. And they're worrying about all the metrics about events that happened after the person went to the advertiser's website, right? What did they buy, like if they buy anything. And so we want to answer both of those queries within a single context. So we weren't really able to do that with the Hadoop ingestion because it cannot append events, right? The only way to really do an append operation in this mode is to have the second pipeline read the first pipeline's output, add the data in, and then do the whole roll up and the re-indexing of those files again. So that really wasn't scalable. So the way that we have decided is to actually modify Druid and to write this new custom shard spec. And what a shard spec is, it tells Druid how to partition how the data is partitioned on disk. So it contains things like the data source, the time interval that this file is supposed to service, right, and a whole bunch of other metadata about what is contained in this file and where it should be stored. So we have now a number of pipelines that each use this namespace shard spec that essentially writes to the same data source but under a different namespace. What that allows us to do is that we have each namespace that is versioned separately, so that if like my team makes a mistake and we need to overwrite some data, or as measurement team makes a mistake, we can do that independently. And we don't really have to worry about deleting each other's data or overwriting each other's data. So that's very, very convenient. But at the same time, both of those namespaces are contained within a single data source, and as a result, we can still query all of the data together. So then, once we figured that out, because we just spent the whole year before launching Druid dealing with deprecating MapReduce, deprecating Hadoop, HDFS, right? We're like, well, we don't really want to go back to that and use Hadoop again to do the ingestion. And as a result, we're like, is there a way to write Druid segment files using Spark? Turns out there is. If you go on GitHub and actually look at this MetaMarkets account project that has the Druid Spark batch repo. And what they really do there is that on the middle manager, they, much like you would kick off a Hadoop MapReduce job, they actually kick off a Spark job to do pretty much the same thing, where they build, right, distribute tasks to different Spark workers, they build all the different index files, and then end up saving them to disk and as a segment file, and then going to the MySQL metadata store, where Druid stores all the information about the segments and updating that. So unfortunately, this project has been deprecated. It's kind of 2 years out of date. So we're like, well, we can't just fork this and like use it, but maybe we can extract some information out of it. And so we took the Spark batch task, which is essentially the meat of the code, and now run our separate ingestion job on the side every day that's doing all of this batch ingestion for us. So the Spark batch task works very much like a Hadoop indexing task would. It partitions data into time and size intervals, which we have configured, right, based on the segment granularity and the number of events that we would want per segment file. We have a whole bunch of Spark tasks that knows which incremental indices to really to create based on that configuration. And then finally, on the same machine, they take all of those indices, they create one final segment file, and they push it into deep storage. Thankfully, we were able to reuse a lot of Druid's internal libraries to do that. So really, all the just specific code of doing that was just making sure that the Spark job was fast, efficient, and was performing to our expectations. And then finally, we of course write the metadata to MySQL. And once the metadata is written to MySQL, Druid on the next metadata update will just know, oh, I have new files, and I'm going to use whatever that version is, if it's a newer version of an existing interval, or a new interval altogether. So we solved the ingestion piece. So we're like, okay, so now we know how to put data in, but we still didn't really know how that data should look like, right? So we really looked into the query patterns that our system was experiencing, and they were pretty common, I would say, right? Customers are usually most interested in the recent data that they just ingested into the system. So recent data obviously is the most important. But in the ads world, it also has two particular query patterns of importance, I would say. And that's year-over-year performance reports, where advertisers might want to know, okay, in Thanksgiving 2019, I kind of sold this much stuff, but how does that really compare to how I did last year, right, at Thanksgiving 2018? And so during especially those holiday times, the query patterns might change, where that might become a very common way to request data from the system. And of course, we have ad hoc polls that are asking for lots of data for a particular advertiser. An example of this might be if an advertiser goes to a new marketing agency, and that marketing agency wants to have their new reports, and they want to pull basically their data since the beginning of time. So it's kind of for each of these, I would say, you would want to optimize your platform differently. And so that was kind of a challenge, like how to do that with Druid, right? So first off, file partitioning, I think, is especially important. If you know that you have an entity that is independent, that basically cannot be queried by anyone else, such as an advertiser ID, like one advertiser's data, you would want to partition your segment files so that that advertiser is not strewn across every file, but probably is contained just within a specific subset. And so then, per query, that will allow you to only query that subset of files instead of all of them. Actually I have a graph here that's showing the difference of latency when we did that, right? So we had a testing tool that ran a certain set of queries over some time period of about half an hour, and we noticed that in a not partitioned data set, the upper green line, I believe that's either the P90 or the P99, which was peaking at about 50 seconds to a minute. Now we were able to reduce to half when we basically partitioned that data. So that really helped us in the recent data case to answer queries quicker. But for those huge polls since beginning of time, right, we didn't really have an answer. And so we started to look into materialized views, which is another feature that Druid supports and can do. And structuring materialized views is a little bit different than actually structuring the main kind of data set. We wanted to look at the query granularity. So in your main data set, when you ingest the most recent data, you might have the query granularity of a minute or maybe an hour, right? Because you want to give those more granular data points back to the customer. But for data from 2 years ago, you probably don't need that type of granularity. So you might just want to maintain data for every day or maybe even every month or something like that. So we created a view that instead of having an hourly granularity, that has daily granularity. But when we did that, we actually reduced the number of files in our system, especially from 2-3 years ago when we didn't have as much data. We reduced the data size quite a bit. And so maybe instead of 100 files, we might have only 5 files or 10 files for a given interval. So we talked about partitioning by advertiser ID, right? But when you have so few files, that actually can be a disadvantage. And the reason is because if you have a couple of big advertisers that get hashed and get put into the same partition, then actually those files will be very skewed. One file might be very large, and the other files might not be. And then querying that large file actually over and over will have more latency than if I just have 5 files that are of uniform size. I open 5 file handles, which isn't very expensive, and then just query those 5 files in parallel. So also, of course, with dimensions and metrics in a view, right? You might not care about targeting information. So, for instance, if we're serving queries like how many women versus how many men click something on the platform, or maybe people in US versus people in France, or something like that, you usually don't care for that stuff that's more than 2-3 years old. And you might just say, okay, I want to know how much spent for like a campaign or something. So that helped us actually reduce the data size and be able to answer those kind of long polls from beginning of time that we also have to serve on the platform. Yep. Cool. So we have figured out how to ingest data, and we figured out how that data will look like, right? But now we have to figure out how that actually Druid setup is going to look like. So nothing too fancy about this, actually. Pretty standard. We have a hot tier, which is that holds all the recent data. It's very compute heavy, so it has a lot of CPUs that we use for that. And the main thing is that we make sure that each server only loads the amount of data that it still has free memory to really service at any given time, so that we can reduce the page swapping to disk as much as possible. And obviously our cold tier, which is the exact opposite, right? It has a lot of stuff that is on disk, it's using cheaper machines, and we don't expect it to perform as well as queries in the hot tier. So that is intuitive, right? But the problem is that query patterns might abruptly change, especially if you're exposing an API to the outside world. Right? Someone might onboard to a marketing agency, and a marketing agency might decide to pull all of their data at a random time that you don't expect. And suddenly the cold tier is at 100% CPU, and our on-call doesn't really know what to do. Right? So obviously the intuitive thing to do there would be to just launch more machines and offload some of that work to those new servers. The problem there is that the Druid autoscaling is not very fast, especially if you have lots of data. If you have like terabytes and terabytes of data, it might take several hours, if not a day or so, for that data to redistribute in between the servers. And so we came up with a solution to this as well. And we call it the mirroring tiers. And what a mirroring tier does is that if we know, for instance, we have 50 servers in the cold tier that are serving data, and we want to mirror the cold tier, we're going to launch a fleet of 50 servers, and then use this maximum bipartite matching algorithm that will actually link each one of those new servers in the mirror tier to a server in the primary cold tier. Once that happens, we don't ask Druid to rebalance. We actually just ask the coordinator, can you give me the segments that this primary tier server is serving? And once we do that, we download that data into the new mirrored cold tier machine and start serving it immediately. And then we do not worry about rebalancing. And the reason is because we know that these tiers, these mirrored tiers, will be short-lived. Right? Once that query pattern subsides, we can just spin down those machines and just serve from the primary tier, which is rebalanced by Druid as usual. So I have a graph of kind of how that looks like. So this is one of our tests, I guess, to scale up data in our cold tier. And there's about 30 terabytes of data at this point. And for without the mirroring tier, we just launch new historicals and wait for it to rebalance. That actually took about 2 hours to do that, right? But with the mirroring tier, it took about 5 minutes. And then we were able to actually service those queries. So that was a really, really big win. Next, now that we have a way to auto-scale, right, we have to talk about the query construction, how the service on top of Druid is going to ask Druid for the data. So Druid supports 2 modes of requesting data, through native queries and more recently through SQL queries. So native queries are obviously the kind of not intuitive, machine-driven mode to query the data. And it's a JSON format that you basically send to the broker server to execute. And there is no optimization that is performed. It's the query that the broker server gets, that's the query it tries to execute. So SQL, of course, on the other hand, tries to be more smart, uses Apache Calcite for the query planning. But of course, as a result, we incur some of the overhead of having to translate a SQL query into a native query first before being able to execute it. There are some disadvantages to this, such as the planning might not be optimal. For instance, instead of using the most efficient query type, it might use less efficient query type. But we thought, as when we were starting to implement the Druid solution, that this might still be the way to go, simply because we didn't really understand the system as well. And we thought native queries were kind of too intimidating. It was pretty overwhelming for us to get going from day one. But there was a problem. And the problem looked like this, right? And so what is this? So this is actually the CPU on the broker nodes that we observed after doing a test run using the SQL queries. And so we noticed a lot of just servers that go to like 65% CPU for a while. We noticed a lot of banding going on. And so we're like, well, what's going on? That doesn't look good. And it turns out that actually there are problems in the SQL planner that were causing this. And it's kind of funny because at around the same time when we experienced this in our deployment, about a couple days later, Jian posted a Jira issue that actually described the problem exactly, right? Which is that the filter expansion in the SQL planner is inefficient, and it might be that the SQL plans that query for a number of hours, right, before it actually starts executing it. So that obviously isn't productionizable. And also that the planning time of the SQL query doesn't adhere to the set timeout, which was another big kind of fall. And so it was very hard for us to understand, because due to this lack of visibility, what really is going on. So we're like, well, because we do get some of the queries into our system that do use this huge number of filters, what can we really do? And so we rewrote basically everything into using native queries. And that was a bit of a fire time for the team. But at that point we felt very confident because we already understood Druid very, very well. And so we had success with that. However, that doesn't mean that SQL is not useful. Obviously, we still, for debugging and for internal tooling that we expect won't be as intensive for the system, we still use SQL to do all that. So hopefully SQL Planner will keep improving in the future. So next, I want to go back to query patterns a little bit, right? So we're using native queries now, and then we're still analyzing what can we do to really help the latency to go down, right? Because at this time, we're still kind of struggling to meet the performance of HBase that we were used to, and we couldn't launch. And so this is one that particularly surprised us. And what this is showing you is the percent of queries that come into the system that return no data, So essentially, some customer was asking for some data, and then there was no record of having that data, or there were no metrics for that data, and then we returned basically no results. And as you see on some endpoints, that is upwards of 80–90% of requests are asking for nothing, right? And so we look at that and we're like, well, the thing is that even if there is no data to be returned, we still have to go to the broker. We still have to plan that query. We still have to send the request to the historical. The historical has to open that file, figure out there is nothing, and return, right? But that's still a lot of requests, especially given the QPS, the queries per second that Pinterest is experiencing. So we're like, well, is there a way to short circuit those kinds of queries? And so we thought about that, and we decided to come up with a solution that every single time we have our Spark job that writes data into Druid, we actually after that have another Spark job that reads the same data and figures out, okay, which entities are contained in which intervals, and creates a metadata store, which is then loaded into our querying service. If in that metadata we notice that, okay, you're asking for an entity that is non-existent or that doesn't have any metrics, we're just gonna return no data, sorry. We won't even talk to Druid. And so that actually helped us cut latency and cut kind of the network contention in the system a lot. So I would recommend highly doing something like that if you're experiencing network issues. Finally, I guess I want to get to the last part of the presentation, and that's the system tuning piece, which is, I think, probably the easiest part of launching a Druid platform, and mainly because the documentation is extremely helpful. Right? And that's something that I don't really say about projects very often, but actually the documentation that explains exactly what how much memory, right? How much direct memory, how many merge buffers, and all those things that setting up a Druid cluster that somebody would need to know is very, very clearly described in the documentation. So thank you, Druid community, for that. But there are a couple of points I want to touch on. And the first one is that in the visibility, it's kind of hard to determine if latency is due to network saturation or CPU load, right? Essentially, am I opening too many connections to the servers, or is my CPU just capped out and I can't process those queries quick enough? So what we learned through this exercise is that if the historical has less than 100% CPU, right, but the queries are slow, then it means that the network is saturated. And part of the reason for that is because Druid is pretty greedy when it comes to making connections, right? And so you might get to the point where just even the TCP stack on the data nodes, on the historicals, just cannot handle so many connections coming in. And that brings us to the next point of, well, how can I have fewer, I guess, less network overhead when I'm executing these queries? Now remember that Pinterest came into Druid from a key-value world, from H-based world, right? And in the H-based world, we really wanted to optimize everything to be point lookups, to be just look at a data point and return that data very quickly. And so each query was very, very simple. But of course, Druid doesn't really react to that type of a query pattern very well, right? It's not suited to serve those kinds of query patterns. So we had to essentially increase the complexity of each query and then figure out where is the sweet spot, how many filters, how many columns I should request in each query in order to get the best possible performance out of the system. Obviously, in the H-based key-value world, we had one filter per query, right? But with Druid, we found that number to be about 500 to 1,500 filters per query to be pretty good, to work very well. So next, obviously, it's very easy, especially when using SQL, to be inefficient and have lots of group by queries going to the cluster. So Druid supports a number of different query types, time series, top, and then group by being the main ones that are returning data. And obviously the time series and top n, which is the queries without a grouping, without a post-aggregation, and top n with just one, to be the most efficient, obviously, versus group by, where it has to do more complex computation. So be careful, especially if you're automatically constructing SQL queries, because you might get into a world where you have a lot of group by queries that actually can be optimized into top n, for instance. So make sure that when you're working on when you're looking at how many queries are being executed on the broker side, that really the number of group by queries that you expect, given your QPS, makes sense for your system. And then obviously, if like number of group bys is 30% or 40% or however much, make sure to tune the number of merge buffers accordingly, right? So that you're not just executing a single group by at a time, but you can actually execute more. So I guess what holds in the future for us? We just launched 2 months ago, so we're still in kind of the phase of growing pains, and a lot of the things that I talked about today, we know where the root cause is, we kind of know how to solve them, but we maybe still aren't like 100% into the implementation of solving that. So that's definitely going to be our focus for 2020. And the next thing is that eventually, for all those huge reports that some advertisers ask to get from us sometimes, can be handled by a different system, right? And since we already wrote like the Spark readers and writers for Druid, and we understand kind of how segment files work, we feel pretty confident that we can write either like a Presto DB connector or some kind of a Hive storage handler that is going to know how to open those files in deep storage and perform the query using Presto or Hive, so that we don't have to consume the valuable Druid resources that are needed to serve those low latency external requests. Right? And finally, of course, we would love, once we get there, to commit a lot of that work back to open source, whether that is the Spark writing, Spark reading, right, or the namespacing shard specs that will allow you to use multiple pipelines to ingest data into the same data source, or maybe even the mirroring tiers, right, which we feel would be very, very useful for auto-scaling work. So, yeah, forward we go. Thank you. I forgot to mention, this is my lovely team that has worked on Druid with me for the last part of the year. And with Philip, Lucia, and Julian, who are sitting here in the audience, and our manager, Wai Hong, who is also here somewhere, but I don't see him. In the back. Cool. So, thank you so much.
So you haven't sent any beta back to the open source?
We haven't committed anything. The question was, have we committed anything back to open source yet? Unfortunately not. Besides creating issues in GitHub.
So instead of a custom shared spec, I'm just curious if you guys had considered trying lookups, SQL lookups, to basically join two data sources and get results out of it.
So you mean like lookup tables on the coordinator? So we do use those to translate like enum values into strings, for example, but I don't think they're really meant to join two data sources that are quite large, right? Like, I don't think that, because, yeah, I wouldn't trust it, because it's something that feels like very flaky at times, the way you have to set it up on the coordinator. We haven't really considered.
We have multiple pipelines producing facts data, so the lookups are more for joining your dimensions and your facts. So if we have multiple pipelines that are producing actual metric data that needs to be effectively viewed in, rather than joined.
Are you trying to use lookups as a way to make joins? Okay.
Thanks.
The scale of data.
Could you repeat the question?
The question was how much data approximately we ingest per day, and I'm actually trying to think of that a little bit. I know that in our hot tier specifically, we hold the last 3 months of data, and I believe the data size is about 10 terabytes for 2 replications. So that's like 5 terabytes for, let's say, 100 days. So however much that is, like 50 gigs a day? More?
They cut this down later. The actual ingestion is a couple of hundred gigs.
Right, so this is the already rolled up. This is not the event level data, right? This is already post once Druid does the pre-aggregation. So the question is, do we need a distinct count user use case in our Druid deployment? So the answer is yes. We actually do use that. We use data sketches to solve that problem. And they work very well if you're obviously not looking for an exact count, but rather for an approximate count, right? If you just want to get to like 98, 99% accuracy, they work great. The one caveat of data sketches is that it might get lost in the details, but they're actually very big to store. So in our case, data sketch data, like the blobs, they take about 60 to 70% of the segment size is just taken up by the data sketch. So be careful, because that data can blow out pretty quickly.
So you actually use that sketches
Yeah, we don't have an exact count use case. Right? That's one of the things that we had to compute in like the age-based world, but we're really trying to avoid it because for the billions of events, it's very expensive to do that.
Thank you.
Can you describe the short circuit use case where if the data doesn't match the filters, you turn the cache? Can you describe the use case or what you do there?
So the question is, can I describe the use case of short-circuiting the data if there are no metrics to be returned?
I mean, not the use case, but like the use case, but how do you figure out something is not there?
How do you figure it out if something is not there? So every single day when we ingest the data, right, we know the entity is kind of like the advertiser ID, campaign ID, ad ID that went into that data set. And so we know if like there was a click for ad ID 1234 at 3 o'clock, for instance. And so once we know that if there's a request for that ad ID for the time interval from like 3 to 4, then we should actually execute that query because we do have an event that happened.
So you have another database where you store accounts?
We don't have a database. It's more of like compressed hash map, I guess, that gets loaded into the query service that sits in front of Druid. So it just keeps everything in memory. This is something like an improvement in the future that we would like to do, is to put this into a distributed like Memcached or Redis or something like that, so that we can actually share that between all the fleet of services.
Yeah, I mean, the reason why I was asking is, all the Druid uses dictionaries for lookups for different filter conditions.
Right.
If something is not there, there's already a short-circuiting path in the code where should return fairly quickly, which is one thing.
Right. So the comment was that Druid already builds dictionaries for all the different dimensions. So it already can short-circuit queries very quickly. That's true. The problem was that we get so many of those queries requesting that essentially no data, that we still have to make a query to the broker, right? And then broker still plans that to talk to the historicals and still makes a network connection to the historical, and only the historical, once it opens the file, it knows that, hey, there's no data. So actually, just doing just that network contention, that was just too much for us. Like we couldn't deal with that, and that was the reason for this implementation.
The paging also made it very difficult to ink data we cared about examination.
Good point. The comment was that the paging also made it difficult, right? So Druid on each historical has a cache where it kind of loads the most recently retrieved segment, I suppose. But then if it has to load a new segment into the cache, it has to dump the old one. So this was actually causing cache swapping, and then the cache hit rate was lower than we would have wanted. Yeah?
Could you talk about the abusive requests and whether they're logged and reported to SIMS or where they go, what happens with those?
So the question is, can you talk about the abusive requests that you get from advertisers? Are they logged, and like how do we deal with that? So honestly, right, that requires a lot of like cross-company work, because if somebody who has access to the API decides to just slam us at 3 in the morning with like millions of requests, we don't have too much, like on my team, we don't have too much control over that. All we can do, actually we use Druid as in another cluster, and we send all of the logs that the query system receives into Druid. And then we have like again for internal debugging, our SQL interface, where we're gonna go, okay, we noticed that there was like huge CPU load for this time period, who is doing it? And we can pull the advertiser ID, right, who is sending those requests. And then if we actually have a contact for that advertiser, we have to tell like our partner operations team, and it's like, hey, this advertiser like spamming us with requests, what is going on, what do they need, maybe we can give them the data another way, and then we solve it just manually. Like there is no automatic way, unfortunately. Yeah.
Sure. So do you mind sharing like what is the cardinality you guys done with some of the data sources, and how do you handle the multi-tenancy? I guess you have a lot of advertisers running queries against it, right?
So can you share the cardinality, and how do you handle multi-tenancy? So for cardinality, for transparency, I think we have maybe 20 dimensions that are going into Druid of varying cardinalities. I think the most, I don't know, what would be like metro or something, or keyword? How? Yeah. How do you know how big, like per day?
For keyword, I mean I guess so. The largest we see in the segment file is like a couple 100,000 unique values, and then with 12 to 15 segment files that we overlap with probably ballpark 12 millions. Within an hour, call it, a couple 2 to 3 million a day.
Okay, so the answer was that for the biggest cardinality, which is like different ad keywords, this can be up to a couple million a day. Honestly, with the cardinality, with like high cardinality of dimensions, that isn't that big of a problem outside of the segment growing bigger, and as a result, of course, incurring latency because you can't roll up, you can't do that pre-aggregation as well. But again, a couple of million it doesn't seem to be so bad. Still, I can execute very quickly. And the second question about multi-tenancy, what do you mean exactly?
Like for example, you have multiple advertisers running query against your Druid data sources, I guess, right? I don't know if you actually share the data sources across all the advertiser, or you probably have one per each. I mean, how do you organize data so that you can isolate them?
Yeah, it's all in a single data source, all the advertisers.
So okay, advertiser is actually one of your dimensions. Advertiser ID is one of your dimensions.
Yes, it is one of our dimensions, yes.
And okay, gotcha. And that is not the highest cardinality in your data sources.
Oh, no, that's very small cardinality,
Okay.
the advertiser ID.
I see. Yeah.
So it's because we also have, for internal purposes, we might have queries that can run across advertisers. Like if, for instance, very big clients might have multiple advertiser IDs, and so when we want to pull like some special report, it's very convenient to query across, right? If we had to do that, like query each different data source and then somehow stitch the data together, especially because Druid doesn't support joins, that would be kind of painful.
Yeah. Thanks.
I'd like to learn more about the mirrored tiers. So are these mirrored tiers triggered by those big queries, like it's ad hoc, or it's we do some pre-scaling up? And also, are these mirrored tiers simply a read-only copy of the data from its corresponding shards? Or how do you solve the data consistency problem with between the actual read and write shard and the mirror and read-only shard?
So the question is, for the mirror tiers, is the in the first part, sorry.
The first part is that what triggers the mirror?
What triggers?
The mirroring?
Yep.
Is it like the incoming query, or it's like we have some metrics for detections and we scale up in advance?
Yeah. So currently it's all manual. So we have alerts that page us if the CPU for a particular tier is higher than some amount for some period of time, and then the on-call person has the lever they can pull to launch a mirror tier for that. The second question was the read and write consistency, right, between the primary and the mirror tier. So that's not really a problem, because if there are new segments that come in, first of all, we're not going to, especially in the cold tier case, right, that data is usually like more than 3 months old, so we're not really going to ever overwrite it. But if it did happen, then those new segments would only land on the primary tier and they would not be served by the mirror tier. Because once the mirror tier gets the list of segments that each machine should serve, it like never tries to get more rebalance ever again. It's meant to be purely, I'm going to launch, I'm going to serve this abusive pattern or this kind of heavy pattern that I need, and then I'm going to shut down.
Okay, and we're only duplicating we're duplicating the data of the entire tier for mirroring, or is like only part of a few shards within that entire tier?
It's the entire tier.
Okay.
Yeah. So each server that gets launched in the mirror tier gets linked to one in the primary tier and just does the exact same data set.
Got it. Thank you.
Yeah. Cool. All right. Thank you.